In this video, I'm taking you through a website called MOEMS. It is the Mathematical Olympiads for elementary and middle schools. This is a very popular organization that conducts math tournaments across the schools in the United States. So about this program, I'll show you, and then in this video, I'm answering one sample paper from the year 2018 from the elementary Olympiads. So elementary school Olympiad exam question paper, I'm going to answer in this. So first, let's see what is this program all about. So this program is MOEMS. This is a monthly problem solving contest for elementary and middle schools. And elementary school meaning is what? The grades 4, 5 and 6 students participate, and middle school means grades 6, 7 and 8 grades students participate in this contest. This is a monthly contest, and every month this contest is conducted across the schools, and so many awards and rewards are given. So this is how the program goes, and this is it. So for conducting the exam, there will be one PCOS. PCOS are person in charge of Olympiads in the various schools, and monthly tests. You see the last three, January 8 to February 2nd, that was a span in which that exam has to be conducted in the school. So the recent exam was conducted in March 4th to March 29th, 2024. In that slot, the exam has to be conducted in one go in all the schools. And the result should be published by the school by March 31st. So this is about this. And here I am clicking on the sample question paper. So here there are two sample papers. Now one sample paper is for the MOEMS elementary school question paper. Here you have the question paper for the year 2018, and the other one is middle school sample paper. So in this video, I'm going to answer the Mathematical Olympiad for elementary school. This sample paper I'm going to answer. So first I'll click on this to download this. Yeah, this is how the question paper looks like. So first let me read out the instruction that is given to the students. So the instruction is, after all questions are being read by the PCO, that is the person in charge for conducting this Olympiad, the student will have 30 minutes to answer the question paper, and this question paper has exactly 5 questions in 30 minutes. So you may not have the pen or pencil in your hand while the PCO reads the set of questions. So when the PCO is reading the question, so there is a listening time. Calculators are not permitted, of course. All work has to be done in the pages provided. No additional paper is provided, and the answers must be placed in the corresponding boxes. So the student starts writing the name and starts with answering the question paper. So let's see the first question. First question is a simple addition. Though it is simple addition, time is a big constraint. So we will add numbers by number. First we'll add 531 to 642. So we'll use the place value. 531 plus 600, that is 1131. So 1131 plus 40 that is going to give us 1171, plus the 2, that gives us 1173. Then we add second number 700, the place value adding. So to this we add 700, we get 1873. To that we'll add 50. When we add 50, first you add 30, then you add 20. 1870 plus 30 is going to be 190, and the 3 is also there, plus the 20, that is going to give us 1923, and then there is in the ones place a 3 is there, so plus the 3, that is a 1926. To this we'll add 864. So first you add 800. So 9 plus 8 is going to be 17. So this is a 2726. To this you are adding the 60. That is a 2786. To that you are going to add the unit place number of 864. That is 4. And this gives us 2790. Then we add 975 to this. So first you add 900 and you get 7 and 9 is 16. So this turns out to be 3690. To that you add 70. To that you add 70. And first you add 10, then you add 60. So you get 3700 plus 60. So 3760. And then you add the last unit place digit, that is 5. So your answer is 3765. 3765. So your answer is 3765. Moving ahead to the second question. The second question is, first 40 counting numbers are written. Okay, how many times does the digit 3 appear as a digit from the numbers 1 to 40? Okay, so from 1 to 10 there is only one number, that is a 3. From 11 to 20 there is only one number, that is 13. From 21 to 30 there are two numbers, that is 23 and 30 itself. 31 to 40, up to 40 it is. So here there is 31, 32, 33 up to 39. So these are 9 of them. So what is the sum total of the numbers where 3 appears? So here it is 1, here it is only one number, here there are 2 such numbers, and here there are 9 such numbers. 9 plus 2, that is 11, 12, 13. So 13 such numbers are there where 3 appears as a digit. That's the second question. Moving ahead to the third question. Ashley has a rectangle made out of paper that is a 8 centimeter and 12 centimeter. So this is that rectangular paper whose dimensions are 12 centimeter by length, 8 centimeter by breadth. She folds it twice, first vertically and then horizontally. So now she's folding this vertically. When she folds it, the length halves, 12 becomes a 6 and width remains the same, 8 centimeter. Then she folds this paper horizontally. So now the latest length is 6 centimeter and width is 8 centimeter. Now she folds this by horizontal. So finally, ultimately she gets a rectangle which is very much similar to the original one, but the length is no more 12, it is a 6 centimeter, and breadth is no more 8, that is 4 centimeter. The question is, what is the area of the new smaller rectangle? So area of the new smaller rectangle, area is length times breadth. So area is going to be length into breadth, that is a 24 centimeter square. So that is the third question. Moving ahead to the fourth question. In this figure, you see the figure, there is a right side. You see I'm encircling that is the figure. In this figure, the whole numbers 1 through 7 has to be placed. So we have the digits of 1, 2, 3, 4, 5, 6, 7. These numbers we have to put in this. 1 in each of the box. Sum of the numbers in the left column, sum of the numbers in the right column, and sum of the numbers in each diagonal are same. Okay, we have to find what is the least possible product of numbers across the gray row. So what you are going to put in this gray row, that is what they are asking. So that should be least, right? So from the numbers 1 to 7, first put the lowest one. 1, 2, 3, no number is repeated. And then what you do, you see the first column, the middle number is 1, and the last column, the middle number is 3. So this 3 is a 2 more. So you have to put in the first columns, the top and bottom, the number such that their sum is a 2 more than the last columns, the top and bottom numbers. So what are the remaining numbers? 2 is already occupied. You have 4, 5, 6, 7. So put here 4, here put here 5, put here 6 and put here 7. Then 5 plus 7 is a 12 balanced. 4 plus 6 is a 10. So 12 is greater than 10. So that is well balanced. So what are the numbers that you're going to put? I'm writing here itself in this diagram. So the number in the gray zone is what they're asking. So 1, 2, 3. And the other numbers are 5, 7. And here 4, 6. Now you can see that some of the numbers in the left column, in the right column, and some of the numbers along the diagonals, all of them are same. And what is the least possible product of numbers across the gray row? That is a 1 times 1 times 2 times 3, that least number is 6. So the numbers were 1, 2, 3, here 5, here 7, here 4 and 6. And 6 is going to be the least possible product. Least possible product, that is 6. Okay, moving ahead to the last question. The last question is about the cryptorhythm. Crypto algorithm is together called cryptorhythm. Crypt means the alphabets will be an algorithm, so arithmetic, like numbers 1, 2, 3, 4, those counting numbers 0, 1, 2, 3, 4. Okay, so each letter represents a digit in a 6-digit number. So butter, better, bitter, batter, butter, that you see here, they are 6 letters, and here the condition is B should not be 0. So what should be the least sum possible when you convert these cryptos to the arithmetic numbers? Okay, so you have the letters A, you have a B, you see E, then you see T, then you see R, then you see U. So here you want least sum. If it is least sum, the first letter should be the smallest. So it can't be 0. If it is 0, it is no more a 6-digit number. So it should be, so B should not be 0. So lowest one is B can be 1. Okay, so I'm starting there itself. I am starting with a better, B-E-T-T-E-R. Okay, let's convert them. B can be 1. And then B can be 1, that's okay. And then E. So because we want the numbers to be small, so you can take E as 0. Then only your answers are in 100,000. Second digit is 0, means number is going to be small. So you have E. T and R a little late we'll discuss. Coming to bitter, B-I-T-T-E-R, B-I-T-T-E-R. So B is a 1, E is a 0. I can be taken the next smaller number, that is a 2. So T and R yet to be decided. So moving ahead, batter, B-A-T-T-E-R, B-A-T-T-E-R. So B is a 1. The next number A. So A should be next smaller number, that can be 3. E is 0. Now also T and R not decided. Then the last one, butter, B-U-T-T-E-R. So here B is a 1. U can be the next smaller number, that is 4. And E is 0. So what is not numbered is a T and R. So T comes first in better, bitter, batter, butter. So you should take T as the next smaller number, that is a 5. T can be 5. So all the T's are 5s. And R can be the last one, that is a 6. So what are the numbers you are getting? The numbers are 105506, 125506, 135506, finally 145506. And when we add them, definitely we are going to get the smallest sum or least sum, and the sum is 512024. 512.24, or you can have it as 5,12,024. So this is the solution to the MOEMS elementary school question paper for the grades 3, 4 and 5.